You know how sometimes you look at something and you think, is that a real pattern or am I just seeing things? We see these kinds of apparent connections all the time, but how do we know for sure? Well, today we're going to dig into a really cool statistical tool that helps us do exactly that, tell the difference between a real connection and just pure random chance. And to do it, we're going to use a question I'm sure we've all wondered about at some point. Is there a real link between being a boy or a girl and being left-handed? Or does it just kind of seem that way sometimes? This simple question is going to be our guide through this whole process.
Okay, so let's look at the actual data. We've got a sample of 300 kids. In that group, we found 12 left-handed girls and 24 left-handed boys. Now, at first glance, you're thinking, whoa, that's twice as many boys. That seems pretty huge, right? But here's the big question. Is that difference actually meaningful? Or could it just be a random fluke that happened in this particular group?
So, here's our game plan. First, we'll talk about the main question, coincidence or connection. Then we'll introduce our tool, the reality check test. After that, we'll set up the ground rules for the test itself. Then comes the main event, observed versus expected. And finally, we'll deliver the final verdict.
All right, first things first, we have to move past our gut feeling. I mean, seeing twice as many left-handed boys feels like a big deal, but in the world of data, a gut feeling is just a starting point. We need a real, formal way to test if what we're seeing is anything more than just random noise.
So how do we do that? How do we run this reality check? Well, we use a classic, brilliant statistical tool called the chi-square test. It's been around forever, developed way back in 1900 by a guy named Carl Pearson.
And the idea behind it is actually super simple. The chi-square test basically measures the gap between two different worlds. The first world is reality, what our data actually shows us. The second is this theoretical, imaginary world where there is absolutely zero connection between gender and handedness. The bigger the gap between our reality and that imaginary no-connection world, the more likely it is that something real is actually going on.
Now, before we can actually run the test, we've got to set the ground rules. And in statistics, that means coming up with two competing stories, or what they call hypotheses. One story where nothing's going on, and another story where something interesting is happening.
And here they are. On one side, we've got the null hypothesis. You can think of this as the default, skeptical position. It's the one that says, nope, there's no connection here, it's all just random. On the other side is the alternative hypothesis, which is our hunch. It's the claim that, yeah, there is a connection. The whole point of the test is to see if we have enough evidence to kick that skeptical, no connection idea to the curb.
To get all our evidence organized, we use this simple little grid. It's called a contingency table. Really, it's just a way to lay out all our numbers so we can see the counts for both gender and handedness all at once. This table is the foundation for everything we're about to do.
All right, this is where the magic happens. It's time for the main event. We are about to put our real-world numbers into a head-to-head showdown with the numbers we'd expect to see if there was no connection at all. This comparison is the absolute heart of the chi-square test. So check this out. The core idea is to compare what we saw with what we'd expect. For example, we observed 12 left-handed girls. But if gender and handedness were totally unrelated, the math says we should have expected to see about 14.4. You see that little gap? The chi-square test just goes through the whole table, adds up all these little differences, and crunches them down into a single score. Now, don't let this formula scare you. Its job is actually really simple. All it does is take every one of those little gaps between observed and expected, does a little bit of math to them, and then adds them all up into one single summary number. And all you have to remember is this. A bigger final number means there was a bigger gap between reality and our no connection theory.
So, after we run all our numbers through that formula, this is what we get. Our final chi-square number is 0.7576. So, what does that mean? I mean, is that a big number? Is it a small number? How do we decide if it's a big deal or not?
And now it is time for the final verdict. To figure out what our number means, we have to compare it to a statistical benchmark, a kind of line in the sand. This is the last step that will finally let us answer our question.
This chart right here shows us exactly how to make the call. See that line at 3.841? Think of that as the threshold for being interesting. For a study like ours, statisticians figured out our result has to be bigger than that to be considered significant. And our result? 0.7576. It doesn't even come close. It's way, way over in what we call the do not reject zone.
And that brings us to our final conclusion.
Even though we saw twice as many left-handed boys, that difference just wasn't big enough to be statistically significant. So we can't reject the null hypothesis. Or, to put it in plain English, we don't have strong enough evidence to say there's a real link between gender and being left-handed. The pattern we saw could have very easily just been random chance.
And you know, this whole observed versus expected idea is incredibly useful. We just used it to see if two things were related, but you could also use it to see if your data actually fits a theory you have, or to check if two totally different groups, say shoppers in New York versus shoppers in LA, are actually behaving in the same way.
So that's really the power of the chi-square test. It's a surprisingly simple way to compare what you see with what you'd expect. Which kind of leaves you with a final thought, right? What are the subtle connections you see in the world around you every day? And how much you test if they're a real thing or just a coincidence?